In topic 2, we're going to take a look at solving equations and then later some formulas. And there is a protocol. But before we do this, I'd like you to look at this little diagram that I've set up here. This is sort of like a scale or a teeter board where things are balanced. That this amount of weight is equidistant from this fulcrum is equidistant from this amount of weight. And we say the weights on each end equal each other. Now if I add a little weight to this end, then they're not going to equal anymore. But if I add the same amount to the other side, they're not the same as they were originally, but they still balance, they're still equal. So this is the principle behind solving equations, that in a sense, with the equal sign there somewhere, it says what's on this side is the same amount as what's on the other side. So the rule is basically, if we take, let's say, our eraser, and let's make a little bit more of a line there, and I take away something from this side, that's not going to balance. But I take away the same amount from the other side, again, it's not the same as what it was, but it still balances. And now finally, if I take away a little bit more, and the same from the other side, again, it's not anywhere near what it was originally, but it still balances. What's on this side equals what's on this side. And what we're shooting for here is that eventually, let's say this over here is an x, our unknown, all by itself, a 1x, and on this side, let's say it's a 3. So we're saying x then equals 3. And the manipulations you did as you went from step to step, adding, subtracting, multiplying, doing the same thing to both sides, those steps are called solving an equation. Now, the protocol, now that we can look at it, is that we remove fractions by multiplying every term by the least common denominator. And I'll review that with you. Once we get rid of the fractions, and we have a call coming in every once in a while. All right, going on, we want to remove grouping symbols, and mostly these are parentheses, but sometimes they could be a fraction bar. And the next thing is, once you have all the grouping symbols gone, there's no fractions, you combine like terms, and then you want to do something that's called transposition, where we take numbers from one side, move them over to the other, changing their sign. Letters from one side, moving over to the other, changing their signs. Now we'll show you that as we go below. And then finally you solve for x. If you have 2x on this side, you're going to divide by 2. This side and the other side. If you have 1/2 x, you're going to multiply again by 2. If you've gotten rid of the fractions, this probably won't happen. And then on a test, you want to check your answers. Put the value you have for x back in the original and see if it makes it a true statement. That's important. You want to get it right. Now for practice, you can put it in and they give you a couple of chances, as you will see. All right, let's go on. Now, in this first example, it's sort of a brainstorming thing. They want to see whether this equation is the same as this equation. And you would tell by finding out, well, what would x be here? Well, 3 times what is 15? Well, 3 times 5. So if x were 5, then this would be true. Now how about this one? If x is 5, so yes, these are equivalent because our value of x in both equations is the same. Now how about this? We have here 5x and a 7x. Now, in order for that to be true, x would have to be 0. So 5 times 0 is 0. 7 times 0 is 0. So x would have to have been a 0. Now, how about this? 5 over 0 equals 7 over 0. Well, first of all, we can't have any mathematical expression in which we are dividing by a 0. And so this is not true in the first place. And you can't have any value of x. Here, in order for it to be true, it had to be 0. Here, it's not a 0. So these are not equivalent statements. And they could have given you other ones that were a little easier than this. But we'll go on and work out how to solve equations. This is meant to be a light review of solving equations. So let's go through, some of the basic steps. Now, we had said we want to get x all by itself on one side. So how do we get rid of a negative 4? And the answer is we would add 4 to this side, and then we would add 4 to that side. Now, when we do so, this cancels out and is 0, so we're left with an x. And when we add this up, it's 20. So we've done a simple step of getting a term off of one side by adding it out, in a sense. And we do that to both sides. Now, the other method we said is to take this term and just bring it to the other side. We can do that. That's that transposition. Taking a term from one side, bringing it to the other, just changes its sign, and we get the same answer. So you could do it this way, where you're showing what you're adding to both sides, or you can just transpose it and get your answer. Now here's a case where we have a fraction, and there's 2 ways of doing this. And I'm going to show you both ways. And again, you're taking notes on this on the other side. We could use what is called, let me write it out here, to end up with a 1x, we want to multiply 5/7 by something to make it a 1. And if you recall from your high school days, we can multiply something by its reciprocal. That is, we just flip this over. So we're multiplying this side now by something, the reciprocal, to make this a 1x. Well, we multiply this side by the same reciprocal. Now, here, the 7's cancel out, the 5's cancel out, and we're left with a 1, and we just write it x. And then here, we know our answer is going to be negative because a negative times a positive is a negative. But we can also cross-cancel. 7 will go into there once, 7 will go into there 3 times, 5 goes into there once, 5 goes into 10 twice. So we end up with a negative 2/3. So that's one way to do it. Now another way is this way. And I'll write it out again. Now we said when we have fractions, if we multiply the fractions by the lowest common denominator, which in this case is 21, that's another way to do it. So we're going to multiply this side by a 21 and this side by a 21. Now we're doing the same thing to both sides. Now here 7 will go into there once, 7 will go into there 3 times. 21 goes into there once, 21 goes into there once. So now we have 3 times, and I think I put an extra x there, which we don't need. 3 times 5x is 15x equals a negative 10. So we've gotten rid of the fractions. This is just another way to do it. In this case, we chose the reciprocal because we had it already, the x on one side, as there was a fraction. So now how do we solve this? Well, we divide by what is with the x. This is called the numerical coefficient. So here this just cancels out and gives us an x, and then we simplify that into 2/3. So notice we got the same answers. We just use different techniques. Now keep in mind that on any test you take, you want to show the work of how you arrived at the answer. One of the things at the end of our course, you take an exit exam. And in that exit exam, you must show the work of how you arrived at the answer. Otherwise, you don't get credit for it. It's the work needed to get the answer that gives you the credit. All right, let's go on. Now, in this next example, we see we don't have fractions, but we have a grouping symbol, parentheses. So what we must do is remove this by distributing this -2 to each term. So I'll write it over here. We get 6x minus 2x. Being careful of the signs, this is a plus 24 equals x minus 3. Now notice we have like terms on this side, so we now group them. 6x minus 2x is 4x plus 24 equals x minus 3. So here we see we have variables, a number, a variable, and a number. We want to use that transposition, step 3, to get the variables all on one side. So this, when it goes to the other side, becomes a negative 1x. So this will give us a 3x. Now this, when it goes to the other side, gives us a negative 24. So we now have a negative 27. Now if you want to physically write in there minus 24, That's okay. But the transposition is sort of a shortcut. Now, how do we get the x all by itself? Well, we divide both sides by the numerical coefficient of our variable, which is a 3. If we do it to one side, we must do it to the other. We are careful of the signs. So the 3's here cancel out. We get a 1x. We just write the x. And this is negative 9. Now, if you put a negative 9 back in here, it makes this a true statement. These steps in an orderly and neat way is the work you need to show to support this answer. And we stress that in our note taking and when we work in our homework logs. All right, let's go on. Now, as we look at these examples, they look like equations. They have an equal sign in them. But there's 3 possible things that can happen when something looks like an equation, but instead of just getting x equals, let's say, negative 9, which would be a conditional equation, there are times when we have something that looks like this. 2x plus 2 equals 2x plus 2. Notice what's on the left is exactly the same as what's on the right. Now, if I subtract out the 2x's, subtract 2x, I get 2 equals 2. And that is a true statement. Why is it so? Because this, when it's exactly the same on both sides, is what we call an identity. And for an identity, the solution is all real numbers. In our number system that we're using, we use real numbers. And all real numbers placed on both sides make this a true statement. Put a 1 there, it's true. A 5, it's true. We often use the symbol, kind of a funny capital R, that's like doubled. That would be all real numbers if you have an identity. Now, we also have something that's called a contradiction. What would that be? Well, if I had 2x plus 1 equals 2x plus 3. Now, when I subtract out the 2x's, I have 1 equals 3. Is that a true statement? No. So when you have something like this, that after doing it you don't get a true statement, you get a false statement. This is not true. You have what is called a contradiction. And for contradictions, there is no solution. So 3 things. In some cases, you're going to get conditional, where you get x equals, let's say, a negative 9. You solve the equation, you get 2 equals 2. The solution is all real numbers, or we can use this symbol. Or you have an equation, you think it's an equation. When you start to solve it, though, you end up with an untrue statement. Then there's no solution. But which is which here? I think we get one of each. So we have to actually solve it. So we get x plus 8, and you're writing this out. 2x plus 6 minus x plus 2. So we've gotten rid of our grouping symbol. Now we're going to group like terms. X plus 8. Now I have 2x minus x, so that just gives me an x. And then I have 6 plus 2, that gives me an 8. So what do I have here? I have an identity. So the solution to an identity is all real numbers. All right, let's check this one out. 4x minus 9 equals 4x minus 4 plus 6. So I'm grouping like terms. 4x minus 9 equals 4x plus 2. Now, when I subtract my 4x's from both sides, I get a negative 9 equals 2. Is that true? No. So this is a contradiction, and there is no solution. But now notice you have the work to prove what you have. All right, let's do this one. Now here we have a variable, a number of variable. We want to get all the variables over to one side. And we want to try to keep the variables positive if we can. So this term on this side becomes a positive 2x, so that gives me 3x. Now I bring the negative 3 to this side, gives me a positive 3. 5 plus the positive 3 is 8. So we get x equals, now we're going to divide both sides by 3. We get x equals 8/3. So this is a conditional equation. When you have this value, 8/3, it makes this equation a true statement. All right, a little background here. Now, in this section, we're going to take a look at a couple of formulas, and we're going to use the technique of solving equations to solve now for particular letters. We want to solve for L. Here we want to solve for H. And here we want to solve for X. So, we have here, and I'll write it again, A equals LW. So this is L times W. How do we get rid of the W? Well, when we have factors like this, we just divide them out. So we don't want the W there anymore, so we divide it out from this side and divide it out from that side. So the W's just cancel out, and we get L equals A over W. Now when you're writing in your notes fraction bars, make them horizontal, like so. Okay, let me write this out here. A equals H over 2 times B sub 1 plus B sub 2. Now we want to solve for the letter H. So we want to isolate the H on this side. But this has a fraction. And this is just one term here. So the rule is you multiply every term, this is just one term, by the lowest common denominator. So on this side we'll multiply by 2. Here we'll multiply by 2. So here the 2's cancel out, and I'm left with 2a equals H times B sub 1 plus B sub 2. And I'll give you some time to copy this down. Now we're looking to get the H by itself. Now this is H, kind of a funny looking H there, that's better, times this. Well, how do we get rid of that? Well, again, we just divide it out. So we're going to divide both sides by b sub 1 plus b sub 2. We could put it in parentheses if you like, and here we don't have to. B sub 1 plus b sub 2. So here they cancel out, and we get h now equals this. And we'll give you a moment. Now, another example that we sometimes use, instead of finding h, how about if we wanted to find b sub 1? Or we could have put b sub 2, but let's do b sub 1. Well, it starts off the same way. A equals h over 2 times b sub 1 plus b sub 2. Now here we want to get that b sub 1, but we still want to get rid of fractions first, always. So we're going to multiply this side by 2 and this side by 2. So then we get 2a equals, now I want to get rid of my parentheses as well, so I can get that b out on its own. So this becomes b sub 1 h plus b sub 2 h. So now I have the term with the h in it here, and I have this term. Well, I don't want this term on this side. I just want the b sub 1. So I'm going to take this term and just transpose it to the other side. So now it becomes 2a minus, transposing it, good tool, b sub 2h equals b sub 1h. So reviewing, I want to get rid of fractions, multiplying every term by the lowest common denominator. Then I want to get rid of parentheses, so I got rid of the parenthesis by multiplying every term by h, so I get the b sub 1 by itself. Now to get the b sub 2h on the other side, I just transpose it, and it changes its sign. Now to solve for b sub 1, I'm going to divide both sides by h. Put a grouping symbol that includes everything on top, and then divide this by h as well. So here the h's cancel out, and I'm left with b sub 1 equals this. Okay, good technique. Now let's do this one here, and I'll write it out big here for you. XA plus XB equals C. And we want to solve for X. Now here's a technique. When X is found in two terms, we put them together like this, and we factor out the x. So I'm going to put the x out, and I'm left with a plus b equals c. So it's sort of the opposite of what we did here. We're taking the x out of each of these two terms by factoring, and we'll do a lot more of that in our next module. And we get this. Now, how do we get the x by itself? Well, we're going to divide both sides by this factor, a plus b, and this side by a plus b. I don't need parentheses on this side. So here this cancels out, and I'm left with an x, and the answer is c over a plus b. Now again, you'll have examples that you'll be working, and we'll be doing some in class as part of our additional exercises to give you more practice.